Hello, folks. Clint Calhoun here. Um, I'm making this video as a response to a video that was posted by a young man on social media shortly following the disaster of Hurricane Helene. And the video was actually a really good video that the gentleman posted, and it explained a lot of things that relate to the damage that occurred from the hurricane, from all the flooding, and how that affected different areas, particularly the Black Mountain, Swannanoa, and Asheville areas. One of the things that he mentioned in that video, and is the main reason for me doing this particular video, is had to do with the effects of the North Fork Reservoir and how the flooding from there actually impacted Lake Lure and the Hickory Nut Gorge area. And I want to kind of shed a little bit of light on that the two um, areas are not related to each other. And so we're going to focus a little bit on that. This is actually going to be a two-part video. The first part is going to relate to the actual Upper Broad River Watershed, which Hickory Nut Gorge is a part of, which Chimney Rock and Lake Lure are a part of, and to kind of look at the aspects that affect flooding in that particular area, and how all of that is related and thus not related to the flooding that occurred in Black Mountain, Swannanoa, and Asheville. So it's because it's important that we understand, even though all these areas were affected by the same storm, the disasters that each area experienced were the result of different things. So there's causes in each area that and contributing factors that are a little bit different depending on which side of the continental divide that you're on. So we're going to be focusing on that. This will be considered part one, which is basically the explanation of the watershed and the factors that contribute to severe flooding, primarily in the Upper Broad River watershed. So just want to make sure that everyone is clear about that. As far as my experience in this particular uh, area, I've worked in the Hickory Nut Gorge area for pretty much my whole adult working life. I started as a naturalist. Well, actually, let me back up. I started working at Chimney Rock Park before it was a state park. Um, Basically, working in the parking lot, working at the Sky Lounge, and those kinds of things as I worked my way through college. And then I ended up becoming a park naturalist, and I spent 11 years working for the park. Not all of them as the naturalist, but a large number of them were. From the park, I moved on to become the watershed coordinator for the Upper Broad River Watershed, and then worked for the town of Lake Lure as an environmental management officer doing sediment erosion control and floodplain management. So, that's kind of where my experience is, and over that time, I got to know the watershed quite well. I spent a lot of time in different parts of the watershed, and um, even today, spend a lot of my time taking pictures, exploring different areas of the watershed, particularly in the Hickory Nut Gorge. And then I get the wonderful privilege of sharing that with my students at Lake Lure Classical Academy, where I now teach high school science. So all this kind of works well together, and I'm always happy to be able to try to um, educate folks when it comes to some of these things, and to make sure that some of the misinformation that's out there uh, is clarified, and doesn't become something that where you hear something and then it gets repeated, and just you get this spiraling, usually downhill effect with all the hearsay that's out there. So hopefully this will kind of help clear up some of the misinformation that is out there. And I'll be addressing quite a few different little things as we get into this first video. So what I'm going to do is I'm going to shift right here, and I'm going to pull up a screen, and we're going to take a tour of the Upper Broad River Watershed. And so hopefully you'll find this tour to be quite interesting, and we'll explain things kind of how they work in this particular area. So what you should be seeing now is a Google Earth view of the Upper Broad River watershed. The watershed is the entire area that is encircled by the funny looking orange line. You can see Lake Lure down here, or if you look at the little hand moving there, that's Lake Lure. And all the way up here, you have Hickernut Gorge. Hickernut Gorge is divided into three parts, and it's in the shape of a cross. And you had to pardon me while I'm, kind of making adjustments here to change my angles, and we're going to kind of fly in a little closer here and get to some things here. So if you notice, the gorge is in the shape of a cross. So it runs basically from west to east, with the top of the gorge being at Girton, and the end of the gorge ends at Lake Lure. It has a north wing and a south wing. Okay, the north portion of the cross goes towards Black Mountain up Highway 9, and then the direction that goes to the south is goes up into Edneyville, and into Henderson County. And so there's basically three streams that make up the primary water that flows through the gorge. First of all, we have the Broad River, and we'll talk more about the Broad River in just a minute. But basically, follows along behind these ridges over here. We'll take a tour up the Broad River here in just a few minutes. But we also have Hickory Creek, which flows down from the Girton area, starts up at Hickernut Gap, and works its way down through the actual steepest part of Hickernut Gorge in terms of dropping of elevation. And then so that makes one part of it. And then we up here on this part going toward Edneyville, we have Reedy Patch Creek, which is less steep than Hickory Creek. But it has a fairly short watershed as it travels down the mountain into the main part of the gorge. It joins Hickory Creek. Actually, I should say that. It joins the Broad River right at Highway 64 and 74 where they come together. Hickory Creek actually flows into the Broad just downstream of where Highway 9 runs into Highway 74. So these streams coming together are what give us the water that flows down the main part of the gorge and into Lake Lure. And from this point here down, this is what has been locally known as the Rocky Broad River. And it's called that because of all the rocks and things that are found lying on the riverbed. And we'll talk about that a little bit more as we move through. So before we get any further, one of the things I want to address here is Hurricane Helene is not the first major flood that has been experienced in the Hickernut Gorge or Western North Carolina, for that matter. There have been numerous significant flooding events, not just in the Hickernut Gorge, but throughout the Southern Appalachians. The Great Flood of 1916 is one that most often comes to mind because it's probably one of the events that has had probably the greatest amount of impact in terms of landscape shaping in any kind of what we call recent history. Recent being within the last several generations. Now we know based on the topography of the land that there's been a great deal more flooding events prior to that. So this is, like I said, this is not the first time this has happened. It has happened repeatedly, and it certainly won't be the last time that this has happened. Some other notable storms that occurred in the Hickory Nut Gorge, at least within my lifetime, that I can remember, was we had a tropical storm that came through in '94 called Tropical Storm Beryl. That storm dropped a lot of water. By the time it reached the Hickory Nut Gorge area, it had downgraded into a tropical depression, and it rained quite a bit. I want to say about 11 inches of rain over a 24-hour period. And then 2 years later, we were hit by a very strong low pressure system that kind of sat down over the watershed and rained about 17 inches over the course of 24 hours, and 11 of those inches came over the course of 2 hours. And that event caused very significant flooding and was probably the worst flood I had seen in my life up until most recently Helene. Helene is significantly worse than the flood of '96, given all the damage that has occurred to roadways and to structures and all those kinds of things. And we'll be talking more about the damage and looking at that from a floodplain standpoint as we move on. But just to reiterate, this particular event, it will not be the last event that occurs in uh, this area. This is all totally related to the way that hurricanes travel. We know and we fear, as far as in southern Appalachians, when a hurricane comes up out of the Gulf of Mexico, they very often will travel north and then will veer off to the east, and sometimes they cause hardly any impact at all. We might get some rain, we might get some wind, and they just kind of fizzle out and don't really do anything. But other times, depending on the strength of the storm and how it tracks, if a storm happens to move up along the Appalachians, starting in northern Alabama and working its way up through Georgia, South Carolina, or in North Carolina along the Appalachians, then we can very often experience some really significant weather that will include flooding and those kinds of things. If the storm tracks the right way such that it puts our area in the northeastern side of the storm, which is the strong side of the storm, which you get the highest winds and largest amounts of rain, then it can be very problematic for us. And that's what we saw with this storm. In addition to that, the area had been drenched for several days by a low pressure system that set up to the west of the Appalachian Mountains and was actually serving as a pulling mechanism that was dragging moisture up from the Gulf. So the area was very wet, soils were saturated, streams were swollen, and this led to what would become catastrophic flooding as Helene came into the area. And so it's important that we realize the dynamics that were occurring. This event is not related to climate change because this hurricane was not any different than others that have hit the southern Appalachians. It didn't come from any kind of unusual direction. This is something that has happened before. This is not the real result or any way related to the government controlling weather with weather satellites or any of those kind of things. As believe it or not, I've heard that conspiracy theory that is out there, and it is not. There's nothing happening in Chimney Rock in terms of the government coming in and taking over property so that there can be lithium mines and all this other kind of stuff. There's a lot of really crazy information out there, and don't believe it. It's just not true. There's no intention to do any of those things in the Hickory Nut Gorge area. So we want to kind of relieve everybody's minds as far as all that goes. So now let's take a look at the watershed. Enough of all that. So I'm going to spin our little map here, and we'll turn it back to the north, so we can kind of take a trip up to the northern end of, or the northern portion of the watershed. So we're gonna go up here into the Broad River community and kind of look, see what all we got up here. So this is Highway 9 down here, and I'm gonna try to turn this a little bit more and get our elevation angle a little bit different so that you can kind of see the topography a little bit better. Let's see, flatten this out a little bit. So you can kind of see how this all lays here. So this is the Broad River flowing down through here. And notice how wide this valley is up through here. Broad River kind of works its way through these little valleys all the way back up in here. And so it's not very steep as far as where the river travels back up in here. And this is where it's really important to point out that the Upper Broad River watershed actually lies in two physiographic provinces. Part of it is in the mountains, and part of it lies in the Piedmont of North Carolina. And this flat portion that we see up in, well, I shouldn't say flat, but flatter portion here, this is all part of the mountains. And it kind of lies in this broad valley. And that's kind of where the broad kind of sits. And then as it comes down into the steeper portion, it's rolling down, begins rolling down Piedmont. And this is what we call the Blue Ridge Escarpment. And basically an escarpment is just a cliff, steep change in elevation between two physiographic provinces. So Lake Lure lies down in Piedmont, and these areas up in here, Girton, Broad River Community, Edneyville, those areas are in the mountains. Okay. And so this makes things, really interesting up in this part of the watershed, and it has a lot to do with how water moves through this watershed. So if we come on up here, let's just move up into the upper portion of the watershed. We're going to go up here to an area called Lakey Gap. Okay, and I'm going to turn our map again so that we're facing kind of to the west. Be looking west. We've got Black Mountain down in the valley there. Okay, we look over here. Let me slide my map just a little bit. Okay, this is the North Fork Reservoir over here, which is mentioned in the video that was made. And in the video, the gentleman talks about how the impacts that occur here impacted what happened way over here in Lake Lure. And I want you to notice some important things here. There's some elevational differences that make this impact impossible. Okay, first of all, this is Black Mountain, and the average elevation down here is about 2,572 feet. Okay, and this sits up on the escarpment, just like this part of Broad River Upper Broad River Watershed does. So this is technically in the mountains. But here at Lakey Gap, uh, the elevation is about 3,038 feet. Okay, so it's almost 1,000 feet higher than, well, actually, it's about 500 feet higher than the town of Black Mountain. So there's this with this elevation difference here, it would make it a physical, geographical impossibility for water to be coming from here and coming up over these slopes and into the Upper Broad River Watershed. But let's talk a little bit about that. Um, this water coming down here and all these mountains that you see here, all this drains down into the Black Mountain area and into the Swannanoa River drainage area, the Swannanoa watershed. Okay, and that's what all this is part of. All this water has to go somewhere, and we had flooded. There was severe flooding in Black Mountain, severe flooding in Swannanoa. All this water is flowing west towards the French Broad River down in Asheville. Okay, so Asheville kind of sits down in a bowl. It's kind of over in this area. Okay, Asheville kind of sits beneath this ring of mountains that surrounds it, and is the kind of on the receiving end of all the water that's flowing into the larger French Broad Basin. The French Broad Basin is on the west side of the Continental Divide, the Eastern Continental Divide. On that west side, everything falls as far as rain and ends up in a stream. Will go into the French Broad River, which is part of the Tennessee River Basin. Once it flows into the Tennessee then flows to the Mississippi and then to the Gulf of Mexico. Over here on this side, back in our watershed again, this is on the east side of the Continental Divide. And therefore, anything that falls on the ground over here and pools up, ends up into the Broad River, will go to the Atlantic Ocean eventually, by way of joining up with the Saluda River and the Congaree River down in South Carolina and flowing into the Santee River and out to the Atlantic Ocean. So it's important to understand where water is traveling and that there are elevation differences that prevent these things from occurring. Doesn't take away from the fact that all this area experienced flooding, but that the things that are going on here are not affecting things that are happening over here in this particular watershed. Now, beneath the Upper Broad River watershed, kind of to the east and south, we have the Catawba River drainage area. This is all part of the Catawba River Basin. And the Catawba River Basin actually joins up with the Broad River Basin way down in South Carolina. So eventually they do have some connectivity, but at this point up here, one is not impacting the other. The Catawba River flows down into Old Fort, which experienced significant flooding, a lot of problems there. And so we want to make sure that we recognize that that is also a connecting basin. The Catawba River also flows east, ends up in the Atlantic Ocean, along with as part of when it and the Broad River basins come together. So we've got the French Broad Basin over here, the Upper Broad Basin here, and then the Catawba Basin here. Okay, so hopefully that kind of clears that up. Now, as we look at this watershed, it's important to recognize that we don't see a lot of houses in this watershed. Okay, the majority of the land is covered in forest. And that's quite an advantageous thing because when you have forested land, forests tend to take up a lot of the velocity of rain when it falls. It absorbs a lot of that velocity, takes away the energy, and prevents a lot of runoff. And that's a really, really important thing because the soils in the Upper Broad River watershed are highly erodible. They contain high levels of silt and sand, and they just don't stick together very well when they become exposed um, by construction or development or landslides or any other type of event that might expose soil. So it's good that most of the landscape is forested. What we noticed though is we do have some areas that uh, they're not covered in trees. These are like little meadows and pasture land and cleared areas, things like that, that have probably been like this for a lot of generations. There's a lot of families who have lived in this area for a really, really long time. And so a lot of this is historical land use, farming that has taken place in the Broad River Valley. And and up in this area, in the upper part of the watershed, that's not necessarily a really, high impact thing. Up here, the river flows pretty slow. Um, the terrain is I mean, it's got some grade to it, and there's some little, drop offs in places, but for the most part, it's not very steep. And the river is very young. It's youthful, it's exuberant, it has narrow floodplains. Floodplains up in here are a little wider because of the flatter terrain. The valley is a little wider. Okay, we compare the Broad River to the French Broad River. Broad River's a young river, geologically speaking. The French Broad River, which is back over in here, is a very old river. Okay, it's probably one of the oldest in the United States, certainly, and even probably in the world. Um, so it's been there a long time, and the separation that has occurred to give us the continental divide. This all goes back to when we had continental formation. Land masses were slamming into each other, causing uplift and raising what we call the Appalachian Mountains today. And so the French Broad River was probably there when much of this was occurring, and it kind of got sandwiched in between mountain ranges. But the Broad River is very young compared to the French Broad River, and we can tell that because of the floodplains and the alluvium that we see associated with that particular stream. Now, we're moving here through this part of the watershed, and then we get to this part right here. Here we have a creek called Flat Creek that joins up with the Broad River, and just downstream from this, the Broad River begins its march in what we start to call Hickory Nut Gorge, right at the county line. This is about the area where the Henderson County, Buncombe County line is, and right in here. The river really takes a steep drop, and this is because it begins falling off the Blue Ridge Escarpment right here in this area. And I'm going to turn my map around here. Okay, so it begins to really drop right in this area, and as it travels down through this part of Hickory Nut Gorge. Now, the steepest part of the gorge is up here in terms of highest drop of elevation. Up here, we've got Hickory Nut Gap, which sits at 2,890 feet. So it's actually lower than Lakey Gap, but it's surrounded by some really high mountains. In fact, the highest mountain in the gorge is right up here. This is Little Pisgah Mountain, and Little Pisgah sits at elevation of 4,412 feet. So it is the highest mountain peak in the entire watershed. We have Barrawalla over here, which is also over 4,000 feet. And this area right here, where Hickory Creek comes down, This is the steepest portion of the gorge. This is 10 miles basically down from here down to this part of the gorge, and the elevation is dropping um, almost 2,000 feet from the gorge up here down to here. So it's quite a bit of drop. So when we look at that, this high velocity stream gradient here means that there's a lot of cutting that takes place into the bedrock. So there's a lot of little small waterfalls and cataracts and things like that as Hickory Creek comes down through here. There's another significant stream that comes down into Hickory Creek. This is called Middle Fork or Middle Fork of Hickory Creek. And it comes down through this little gorge here. This is also a very steep creek. There was a lot of damage that occurred up here in this little drainage area. Um, so, in fact, they actually have had to create a new pathway out to get over to Girton with the damage that occurred up there. So Hickory Creek comes down here to Bat Cave, which is joined by the Reedy Patch Creek, which is right back up in here. And here in this part of the watershed, we start seeing quite a bit of development. Particularly, there's a lot of houses up in this portion, down 64, and on some of the slopes, there's some housing developments and things like that. And and this is a trend that we begin to see as we move down into the valley. Of course, this up here, because it's less steep than some of the terrain over here, it better supports houses and things like that. But one of the things that we really notice is that as the steeper it goes, the steeper the land gets, the more limited it becomes as far as where you can actually build houses. Okay. And so here we have a very narrow floodplain because the river is confined between two steep mountain ridges. Okay. We have the north side of the gorge here and the south side of the gorge. This is Chimney Rock right here. And they confine the Broad River after it joins up with Hickory Creek and Reedy Patch Creek. You have all this water volume coming down through the main part of the gorge. And your development is generally, for the most part, limited to the valley floor. Now, there are some little subdivisions and things that are perched on the sides of the slopes here and some of the less steep portions. And so there is some construction in those areas. But for the most part, your development is confined to the lower slopes and down by the river. This is where Chimney Rock Village is and so forth. And the reason for this is many of these places, many of these homes and so forth that are down in the heart of the gorge, some of these homes are really old. They've been there a long time. Some of them are multi-generational homes. Chimney Rock Village, many of the stores that are there have been there for a long time. And much of many of these older homes have been there since the Great Flood of 1916. These were rebuilds or things that came after the area changed after the 1916 flood. So a lot of history down in here. Now, Lake Lure is the damming up of the Broad River. The Lake Lure wasn't constructed until 1926, and so it would have been after the 1916 flood when that came to be. But because of its location at the foot of the watershed, it receives all of the water that comes from the whole 94 square mile Upper Broad River watershed. And then it deposits all of its material, all the water that it can discharge, comes out the Lake Lure Dam and goes downstream through the Broad River and heads on, makes its way eventually down into South Carolina. So we can look here at the landscape here. We can see these big cliffs. These are the cliffs of Rumbling Bald, up to Shumont, Cedar Knob, and so forth. We got the cliffs of Chimney Rock over here. So this is where the Blue Ridge Escarpment uh, transitions from Piedmont down here to mountains up here. So this is important stuff to understand. Now, when we look at flooding, and I'll cover more of this in the second video, we have to think about the fact that all this water has to go somewhere. And when you don't have a wide floodplain, it gets concentrated down the main part of the stream. In the French Broad Basin, because it has wide, really big, wide floodplains, similar to the Mississippi River, there's a lot of room there to disperse floodwaters. It doesn't mean that the waters aren't going to get high, but it means that when those waters get high, that water tends to spread out. And so it doesn't have as much energy in the zone that it spreads. Okay, which is good because there tends to be less destruction when that happens because water can then just kind of fill in the gaps. The energy is mainly down the center of the stream. But in a case like Hickory Gorge, where it's steep, it's narrow, it's confined, there's not a wide floodplain for the distribution of all that energy. And so this stream, as it comes through here, because it's moving at high velocity, it's choked because it's loaded with sediment, it's loaded with debris, and all this other kind of stuff. It's picking up all this speed and just cruising down through here until it reaches Lake Lure. And that's hugely destructive because there's nothing to dissipate that energy. So that means that all that water, as soon as if it meets any kind of obstruction, whether it be a bridge, whether it be an island or a series of boulders or a house, anything like that, it's going to create an obstruction, which is going to hold energy for a little while, and then that's going to blow out. Anything that's behind that is going to all that water is going to be discharged at in high energy fashion. And so this is why we see the kind of destruction down through here that we have seen. In the 96 flood, and I remember this quite well because I was working at Chimney Rock at the time, this little section of road right here blew out. This is where the covered bridge was more recently constructed, and there's a housing development over here and all this kind of thing. This whole section of road right here blew out. Also during that time, if you look there, you can see some landslide areas. This right here is a landslide scar. This was recently opened up during Hurricane Helene. It has slid again and slid through some houses that are located up here behind the Esmeralda Inn. There's a slide here that probably has opened up and slid again. And there's even some more over here. You can see some landslide scars over here below where the old Indian village was. This is where the Indian village for the Last Mohicans was filmed. And there's a slide scar over here. So you can look around and you can find all kind of places where landslides have occurred during some of these major events, which is one of the reasons why it's not safe really to build in some of these areas because of the likelihood that that soil is not very stable. So you can see that the terrain itself creates a lot of interesting challenges and why a flood, especially one where you get anywhere from 20 to 30 inches of rain, can be particularly destructive. And so that really is an important thing to highlight here. I'd say that these storms are almost generational in terms of how often we see a high impact flood. I remember the 96 flood, which was the worst flood that I had seen in my life till Helene. There was Hurricane Francis in 2004, which did a significant amount of damage, especially down in Lake Lure. There was a lot of retaining walls that were damaged. It was foundational damage to a lot of homes, things like that. And I remember the discussions that we had, because one of the problems that always comes is we get all this sediment that comes down the river during these high flood events, and it tends to cause sedimentation here in Lake Lure. But the discussion that we would often have when I was working with the town was, when's the next event going to be? How much is going to get deposited in the next storm? Because every time it comes a big rain, particularly a big hurricane, we end up with more and more sediment ending up down here in the lake. And it costs the town a lot of money to remove sediment. Uh, After the 96 flood, all the sediment that came from this entire watershed ended up down here in the lake, and it cost um, over $2 million to remove the sediment that choked the lake here. And it only extended out into about this area right here. Now, when we look at the amount of sediment that is in the lake, um, and this is pre Hurricane Helene, there's a sediment plume that comes out to about this part of the lake right here. And this is from all those storms that have been bringing more and more sediment down here. So you can see that the impacts of a major storm are vast. They affect the functionality of the lake in terms of recreation, power generation, um, and more importantly, they affect the lives and livelihoods of the people that live in this part of the gorge, because there's just no way that you can escape um, the amount of water that can potentially come down through this gorge. And so this is the reason why so many people have been affected. Um, you have one major highway going through Hickernut Gorge until you reach Bat Cave. Then you have highway going north, highway going south, and highway continuing west. But if something happens in the main parts of the gorge where it's the steepest, if a road washes out, just happened, then you're stuck. And so many of these areas that are naturally prone to flood, prone to landslides, that's what they have experienced in this valley, in this watershed. And so hopefully by looking at all this, you see the terrain here, it makes a little bit more sense as to why this happened like it did here in Hickernut Gorge. Now, one of the things that I'll be doing in the next video is talking about the actual flooding itself and the impacts that occurred to the river and to the structures that are found in the gorge. Um, and I'm gonna try really hard not to be too controversial in some of the things that I say in that, because some of it's because this is still a little bit raw to a lot of folks. I don't want to make it sound like, well, this is somebody's fault this happened, because that's not the case. But it is an opportunity to learn some things about how water works, what it does when it becomes impeded by structures, by debris and things like that. So it's an opportunity to learn how floods work, and what we can do to reduce the impact of floods. So I just want to make sure that kind of give a preview of what's to come in the next video. So as I close this one up, I want to just say that we are praying for all the people who have lost so much in this storm. Our thoughts and prayers are with you. We know that there's a long road to recovery, and there's really no way unless you're there, unless your boots on the ground, unless you're actually you've lost your home, lost your possessions. There's no way for us to really, for those of if we're not there, to really truly know what you're going through. All we can do is just see the images and basically mourn with you, pray for you, and just offer our time and effort to help with the rebuilding process. Um, it's a really hard thing to kind of sit on the sidelines and watch a community with so many people that I know and friends with, knowing that I can't get in there to help. One of the things I do is take pictures, and not being able to get in there to basically um, photograph such a historical event is very tough for me. But it's also one of those things I don't want to get in the way. I have been able to do some volunteering and to help do some things on my own. We've had our own issues um, as far as getting power back and things like that. And so those kind of things can have an impact on what we're actually able to do. But just want people to know how we are thinking about everybody that's been impacted, not just in Hickory Wars, but all throughout Western North Carolina and in the Southern Appalachians. Our thoughts are with you, and just stay strong. And hopefully, we'll see you in the next video.